Hey guys, welcome back to your design school, and it's day 9 of Fusion 360. And if you have been following me around, you know that we always start a fresh day with a fresh wallpaper. So here it is, one of my all-time favorite KTM RC8R 1190. So as you all know that I own a 2015 KTM RC200, but what you don't know is I even own a KTM RC8R. You won't believe, right? So let me show you. So here it is. As I told you, I own the KTM RC8 1190. I was talking about this, not the actual one. That will take some time. You have to wait. But till then, I own this scale. It is of 1:18. As you can see, I have bought it from the Amazon. I have provided the link in the description. If you want, even you can buy. The execution of this bike is really good. As you can see, they give you this type of showroom type of box along with the bike, which is really nice. You can just keep it anywhere and it won't get dusty, which is again very difficult to clean. So let me just open it up. The box. Okay, enough of this beauty. We'll get back to our session. I hope you liked the review. So please tell me in the comments if you really like that. I'll be continuing with that. Not actually the scale one. I'll be reviewing the actual bikes. Okay. So if you have seen the previous videos, you know that we have practiced a lot of sketches and parts. And recently we made a piston and a connecting rod. So in this video we'll be making a crankshaft. Okay. So first thing first, we always start with our 3 basic steps. Okay, the step 1 is to open up the software. Then step 2 is check your internet connection. Step 3 is download this image and just take a printout or send it in your phone or something and keep it handy. It will help you to design faster. Okay, so with that, let's start with our today's project. So this is the crankshaft of a single cylinder engine. Let me show you how it looks actually. So there it comes. So this is how it looks in actual. Okay. This is a single piston crankshaft. Only one piston can be mounted on top of this, mostly used in single cylinder low volume bikes. So this is what it looks. So this is a multi-cylinders engine's crankshaft, where you can mount couple of pistons on top of this. Okay, so this crankshaft is of a multi-cylinder engine. As you can see, this is of, I guess, inline 6-cylinder engines. So this is where the connecting rods will go, and this is where the main journal bearing will be. Okay, so we don't have to bother about that. We are just making a crankshaft for a single cylinder engine. So we'll get started. Okay, so this is what it looks in its 2D form. So here are some dimensions they have mentioned. Okay, so we'll start making this. So first we'll start with these 2 massive disc-like structures. Okay, so this is where the connecting rod will be mounted, which is little bit offset from the center, and it will create some centrifugal force to just To avoid that centrifugal force, these balance weights are added to the crankshaft. So you won't understand in this picture. Once we made it and convert it into the 3D, you'll start understanding a little bit, okay? So we'll start. So we know the diameter of this massive discs are 100 mm, okay? And those are 8 mm apart from each other. So that is all you have to remember for now, and it is 16 mm in thickness, okay? 8 mm, 16 mm and 100 mm. Just remember these dimensions, okay? We'll go back to the sketch. We'll use the right plane and we'll start sketching it up. So first, all we need is, since we know it is 8 mm apart from each other, we'll make it 4, and the diameter of the disc is 100, so we'll make it 50 mm as the radius, and we know the thickness is 16, so we'll make it 16 right there and just connect it to its origin point. Okay, now connect it here and it will become a rectangle. We'll delete this portion, we don't need it for now. Okay, and another thing we'll do is we'll make a construction line which will be useful for the, just make it 300 to be on a safer side. Both sides I have made 300 mm construction line. Make sure it has to be construction, okay? Just finish the sketch. Use the orbit. Now what I'm gonna do is select the sketch we have made and I'm just going to revolve it around this axis. As you can see, the construction line that we have made, and it will revolve just like that. Okay, then press OK. Okay, so our one disc is ready. So we won't make the second one, we'll just mirror that thing. We'll select the right plane, go back to the sketch. Then I'll select this portion, I'll select this sketch and I'll mirror it to the mirror line. Just turn on the origin and select that blue line. For objects, select the first sketch that you made. Sometimes that won't work out, don't worry. It won't take too much time even if you make it. So make that once again. We'll make that as 4 mm right there and there. Vertical 50. Again horizontal 16. And we'll connect the remaining portion and trim out the excess one. Finish the sketch. Do the same for this as well. Select this green line as your axis. Let the operation be new body. Hit OK. and there are our two discs, 8 mm apart from each other and 16 mm in thickness, and diameter is 100. Okay, so you might be wondering, there is a cutout here and that we didn't make. Don't worry, I'll show you how to make that. That isn't essential now, we'll make that later on. Okay, now we'll make the right hand side portion of the crankshaft. So it is 7 mm in thickness and 38 mm in diameter. Okay. So what you can do is repeat the same procedure that we used to make these discs, or you can even select this plane and using circle command you can extrude it from there also. So this is what we did earlier, but this time we want to change it a little bit. So I'll select this plane, go back to the sketch and take center and start from its origin, make it 38. Okay, 38 right there. Finish the sketch. I'll select that portion. I'll extrude that out. This time don't use Revolve or you'll mess it up. Okay, we know that the thickness of that disc is 7. So I will make it 7. This time the operation has to be joined. Okay. So it is right there. 38 mm in diameter and 7 mm in thickness. So next cylinder is this extruded portion is 15 mm in thickness and 25 mm in diameter. This time also we'll repeat the procedure. This is slightly easier than the earlier that we used. Always start from the origin. Get 25. Finish the sketch. Select the sketch. Extrude. Make it 15 mm thick. This is where our journal bearing is going to sit. Okay, then we'll make this. As you can see, there are some horizontal lines on top of this end portion. So these horizontal lines are just some slots. This can't be made right now. I'll show you later on how to make that. We'll just make a cylinder of 18 mm in thickness and or 18 mm in width and 18 mm in diameter. So these slots just go and mesh with the other gear parts. So we'll do that later on. Just for now we'll make it a cylinder. Select this portion, go back to the sketch, again use circle, start from origin, make it 80, finish the sketch, select the sketch, extrude it out to 18 mm, like there. That is how it looks. Now we'll start with the left hand side portion of the crankshaft. For that we'll just continue with this sequence. So as you can see, this cylinder has an edge that you don't have to worry about. Just make it as 38 mm in diameter, and I guess how much it is. 32, I guess it is. So your dimensions are barely visible. I'm just gonna consider that might be 18 since this is 16 and this looks slightly like 2 mm larger than that, so I'll make this one as 18. So this time select this plane and make a circle of 38 mm in diameter and extrude that circle to 18 mm. Does that look big? No, fine. Again, there's edge is there. I guess 2-3 mm of edge is there, so it's fine. Then we'll go to this. So this one is 34 mm in diameter and 16 mm of width. Repeat the same. Make it 34. Use the sketch and extrude that for 6. Okay, we'll move on to the further one, which is again 12 mm in width and 25 mm in diameter. So this. Make it 25 and 12. Okay, so again your edge is there, don't worry about that, I'll tell you. So the last end part of the shaft has a tapered cylinder. Okay, as you can see, it isn't equal, it is slightly tapered. It starts with 20 mm diameter and ends with 16. So we'll do that as well. Okay, so this time we can't repeat the same procedure that we have been for so long. Let me show you, otherwise you won't be able to understand what I'm saying. I make this as 20. Finish the sketch, select the portion I have made just now, extrude it for 38 mm. Oh sorry, 32 it is. So as you can see here, that slant won't be there, it won't be slant. And even if we change the taper angle for like -5, it will be there slightly, but we won't be able to understand whether this circle's diameter is exactly 16 or not. So for that I have some other procedure that I will show you. Just delete that circle. This time what you have to do is go to the sketch, select the right plane and use the line command. We know the diameter is 20, so I will make that as 10 right there. Okay, then we know it is 32 mm in width, so 32 is right there and ends with a diameter of 16, that means radius 8, and we'll just connect this portion. Okay, finish the sketch. Yeah, you got it right. Now this time we're gonna revolve. So we'll revolve, select this, for axis, select the lower portion. We are right there. Okay, so that is what it looks like, and still there's one more part to go. That is 12 mm in diameter and 15 mm in width. So we'll make that real quick. Just maybe 12. Finish the sketch. Select the portion. Extrude it to 15 mm. And now the crankshaft is slowly started taking its shape. Okay, so I don't know whether you're able to see this or not. Okay, so there are some hatching lines in this. That means this portion is threaded. So we'll do the same. We'll select this. We'll go to create, and there's a command called thread. Use that. Now tell me what's easier than that. Don't mess with any of these things. Just hit OK, and you have your threaded portion right there. Okay. So what else we are left with? Okay, we had to make these slots now. So we'll make that as well. For that, we have to select this plane. Go to sketch. Now take a circle, turn on the construction, and make that circle of 18 mm, just to coincide with the existing one. Okay, so they have not given any dimensions for that. We'll just assume it according because those are just some slots right there. So what we'll do is we'll take a line, make sure it has to be construction, make that as 8 mm or 7.5 would be perfect. Okay, now what you have to do is again take the line command. This time turn off the construction, make it 0.5 mm. Do the same for the other side also, and just connect it to the upper circle where you get the X mark, just like that. Okay, now select this conic curve, or you can even select the arc and select the 3 point. Select this, and select where it gets the X mark. Okay. Then finish the sketch. So that is what we made just now, like that. Okay, and extrude it. This time we don't want the function to be new body. This time we want the operation to be cut, so we'll select that and make it negative 80 because we want that cut to be there for this whole cylinder, but not to exit this cylinder and go into this one. Okay, so we'll make it 18, then just hit OK. As you can see, our one slot is ready. So we don't have to make each and individual slots like that. There's a function called Revolve that we'll be using. So go here in the create section and select the command called pattern, and in that you have to use the circular pattern and select whatever we have made just now, that slot, single slot that we made. So here it will show the objects have been selected as one. Now we have to select the axis. For that, click there on the select button and turn on the origin and turn off the bodies, and select the green line that you're seeing there. Okay, again turn on the bodies and turn off the origin. So here you can select the quantity as per your requirements. If I select 50, it will show the angular spacing is full, subtrace is on, quantity is 15, compute option is adjust. Don't mess anything with this, just click OK and there it will be. The slots are ready. This feature is really helpful while you are making any circular pattern. You don't have to make anything individually, just you have to make a single of that and you can just pattern it around. Okay, so we are almost there. What else we are left with? So we have to make this slot. Okay, so for that what we have to do is, let me just zoom in it a little bit. So we need to cut this portion out or else where our connecting rod will fit. Okay, but we don't know the dimension of this, but what they have given is from the origin point it is 10 mm. Okay, so we know that this disc is of 100 and the radius of this disc, that means from this point to this point it is 50. 50 minus 10 will get this as 40. Okay, so we'll do that. Go to the sketch, select the right plane. Select the line, turn on the construction, make it 10 mm apart from the origin, and there we'll make that rectangle. Okay, so we know the vertical dimension, it is 100 divided by 250 minus 10, 40, so this is 40, but we don't know the horizontal dimension of this. So for that what we'll do is, we know this is 16 plus 8 divided by 2 because we have to start from the center. So 4 plus 16, 20 minus 12 will get this portion as 8 mm. So I'll select the line. So I'll start from here and make that as 8 mm. Then we just have to make a rectangle here. So I'll start with a 2-point rectangle. I'll start from here and I have to make that as it is asking for the horizontal dimensions. I'll make that as 16 and the vertical it will be 40 as I told you before. Hit enter. So we have to delete that line we made. Okay. So once we have made that, we'll extrude it. Select. Oh wait. Select the part. Extrude it. So there are no limits for extrusion of this because anyways we are going to cut that part out. Just make sure that it has to be symmetric. Okay, just select the symmetric and pull it out as much as you can. But make sure you have turn on the cut operation and then hit OK. And like that, we got a slot right there. So this is what it looks like in 3D. Now what are we left with? Okay, so this little shaft we have to make where the connecting rod will sit. Okay, so here they have given the dimension. If this isn't visible, go here it is visible. It is 30.5 mm apart from its origin. So we'll make that. Go to sketch, select right, okay, and go to line. Make sure your construction is on. Make it 20. Let the construction be on. Make it 30.5. Okay, so now turn off the construction. Just use the regular line. Make it 40. So you might be thinking like, why this guy is making just a line right there? Okay, so there's one more command that I haven't told you so far. Just first select this line that make, go into create section, and there's a command called pipe. Okay, if you select that and make the operation as join, now you can define its radius. So we know that the radius of this shaft is 20. We'll make that as 20 as well, and that is how it looks. Okay, don't mess anything here, just click OK, and there it is. This circle is looking really ugly here, so what I'll just do is turn off the sketches. That circle there is really annoying me. I have to do something for it. So what can I do? Okay, I'll edit this sketch and I'll play around with these dimensions a little bit. I'll make that as 18 and this one as 35 or 38. Would be better, I guess. Right there. And finish the sketch. went off. Thankfully. Okay, the circle in this 2D sketch defines that there is a material been removed from this portion just to do some proper balancing of what I don't know exactly, but they have removed some material from here, so we'll do the same. We'll start with this one first, which is 15 mm in diameter. Here they have written it as a hole. So select either this or this, it doesn't matter, select any of the plane. Use your circle command as always. Before that we have to make a line construction one that has to be 30.5. Where it went? Oh, it became 300.50 watts. 30.5 I said. Okay. Circle again, turn off the construction, make it 15, hit enter, finish the sketch. Oh, where it went? Okay, I've turned off all the sketches, so I have to turn them off. Okay, now select that circle, rotate it a little bit like that, and then extrude it. Dimensions or distance doesn't matter, just pull it out, make sure it has to be cut, and hit OK, and there it is. Okay, we have to go with 2 more circles. Let me just zoom in a little bit. So as you can see there, it is 15 mm above the origin line, and those 2 circles are of 25 mm diameter each. Oh sorry, it isn't 15, it is 25. Your little bit misprint is there. So the circle is 25 mm apart from the origin and 25 mm apart from this vertical line, and it is of 22 mm diameter. So that 2 circles we have to make of same dimensions. So we go to the sketch, turn off the bodies, select this plane, again turn on the bodies. Okay, then go to line, turn on the construction, make it 25. Okay, then another line you make it of same dimension, and then select the circle but turn off the construction and make that circle as 22. Okay, then again turn off the bodies, select the circle that we have made just now. Or wait a second, we don't have the mirror line. Okay, so just make a mirror line, dimensions doesn't matter, select that circle, go to mirror, select the mirror line as that vertical line, hit OK, and we are having here 2 circles. Turn on bodies again. Do you think I'm going too fast? But you have to be fast. Let me just select that circle and the other one as well, but before that you have to press and hold the control button or you won't be able to select both of those. Go to extrude, make it symmetric, and operation has to be cut. Again, the distance doesn't matter, just hit OK, and there we are. Save plenty amount of weight right there. Now it is looking nice. Okay, do you think it is completed? No. Still there are some final touch-ups that we have to give, such as here some edges are there again here. Okay, so we'll do that. So here they have mentioned it as 3 into 45 degrees. I don't know what does that mean. Anyway, what I'll do is select this, again select this one, select both the edges of the discs or patterns, weights, whatever you call it, and go here in chamfer. We'll play around with some numbers. 45 won't be possible, 5 is too much, 2 looks perfect, I guess. Is that what it looks in the image? Yeah. 2 is perfect. Okay, I forgot this one, so make the same for this also. Are there any more edges? Okay, here only 2 are there. One is on the second number cylinder and another is on the 4th. So this is the second, or this is the second. Okay, so this is the second and this is the 4th, right? Yeah, so I'll select that first. Again, they have told you somewhat like 45 into 2, but don't bother about that. Just go in chamfer and so keep trying the numbers until you get this slant shape meshed with this upper cylinder. So if I type 1, you can see the little gap is there, so I'll increase that to 2. It looks perfect, but that slant is not good enough, so I'll make it 3. Won't work out. 2.5 now, 2.3 now, 2.1 now. So 2 is perfect. Then I'll select this one, again chamfer. Not combine, just escape like this. Go modify, make it chamfer. 2.5, 2.8 won't work out, so 2.5 is fine, I guess. Finally it is there right now. Is there anything we left out? Just check once. Okay, slots are there, threading is there, edges we made. We reduce the weight and I guess it's over. That is what all we have to do. Now let me select the orbit and check it once again. Okay, so that is what it looks like. So this is where the connecting rod will go. On top of that, a piston will go with the help of a piston pin. And okay, so we have to define a material for this. So for that, you have to select anywhere on this crankshaft like this and go here into appearance. Okay, so once you go there, just scroll down a little bit, you'll get a lot of options like metal, liquid and all those things. So we know that this can't be made out of liquid or something, so we have to go with the metal. So as soon as you open metal, again you have bunch of options right there. So we know mostly it is made up of iron. So we'll go there, and this is what it looks like in cast iron, but this is just raw, it is straight from the mold. So we want it to be a little bit polished, so we'll select this, just select it like that, drag it over there and leave it. Do the same for this portion also, and our crankshaft is finally ready and finished with a nice polish. Let me just turn off the grid so that you get little better visibility. Now it is having some nice shine on top of it, right? Hope you learned something from this video. Until then, keep grinding, keep practicing, and see you next time.